Okay, here's some more problems in section 4.5. This is number 9. And they want you to determine the amplitude and period of each function, then graph one period of the function. One period of the function, that's nice. And this one is going to be, number 9 is y equals 3 sine of 1/2. X, 1/2 x. So first of all, I have to figure out the period, so I know how I'm going to do my scale over here. So remember, the period equals 2 pi over b, so period equals 2 pi divided by 1/2. So 2 pi divided by 1/2 is the same thing if I multiply the top and the bottom by 2. That's going to be 2, and that's going to be 1, so that's going to equal, or invert multiply, 2 pi times 2 over 1, which is 4 pi. So that's your period, 4 pi. So when I set up my scale here, I can kind of eyeball this, and this is going to be, and I'll just make this 4 pi is my period, so I'll just call this 4 pi. So I can kind of eyeball that about halfway through that. That's 2 pi. This would be in the middle 3 pi. And in the middle here would be pi. So that's how I'm going to subdivide my interval, because I've got a period of 4 pi. And my amplitude is 3. I'm going to bring this down a little bit. So this would be positive 3, and this would be negative 3. And that's 0. There's my y and my x-axis. Okay? And then we just have to kind of, there you go, you got your period. So it's real easy to divide into 4 spots, and like we did before. Now this is going to be, the sign of 0, 0. I start at 0, and then I go to 1. My first subinterval, I've got my 4 subintervals, my 5 points. I go to 1, but I've got to multiply that by 3, so I go to 3. 0, negative 3, 0, the same deal. Goes up like that, come like that. And there you go, nice sine curve. All right. And then number 11, what did that one look like? Number 11 was y equals 4 sine of pi x. Oh man, 4, I'll have to change my scale over here. Y equals 4, I got an amplitude of 4 sine of pi x. So the period equals 2 pi over b, and the b is whatever's in front of the x, so that's 2 pi over pi, and that's 2. So the period is 2 radians. We talked about this before. Remember, a radian is about 57 degrees, so that's going to be about 114 degrees. You know, if you want to get an idea of the scale, I did this in class, so you can get an idea of the scale. Remember pi radians, let's put that over here. We'll call that pi. This is x and this is y. So pi, which is about 3.14, and we've got 2 radians, so I'm going to call this 3. That's 3.14, and I'm going to try to trisect this, and that's kind of a hard thing to do. That historically, I mentioned that's in some classes that's hard to do, so I think I kind of trisected that pretty good. Okay, not bad. It might be a little bit off over here, but we'll be happy with that. So this might be 1 radian, and this might be 2 radians, 3 radians, and that's pi radians, a little bit more. That gives you an idea of the scale relative to what we've been doing in radians up here. Okay? All right, so my period is 2 radians, so this is going to be what I'm going to divide into 4. That's going to be 1 period, so I'm going to just think about this area over here. And I'm going to divide that into 4. So I've already divided into halves by 1. So this would be 3 halves, and this would be 1 half. So that's 1 half, and 3 halves, and 2. So I've divided 0 to 2 into 4 parts. Now my period is 4. Now the way I set my scale up here, I've got some problems. So I'm going to call this 2, and I'll call this 4. Negative 2 and negative 4. And then I'm all set. Once I got it set up, same thing. 0, 1, but now 1's going to be 4, so that goes here. Back to 0, negative 4, back to 0, and there's 1 period. And I gave kind of a reference for pi. It's always 0, 1, 0, negative 1, 0. And you can get that off your unit circle. Sorry about that. Looks like that's got to be lined up down there. Something like that. Okay? It's pretty close. Okay? So that's number 11. And then number 13. I think I can slip this one in here. Let's see, number 13. I was going to use a different color. Sorry about that. Okay, y equals number 13. Negative 3 sine of 2 pi x. Oh man, negative 3 sine of 2 pi x. So you might say, well, this is going to be a hassle. Well, yeah, not that bad. First of all, we have to find, we know the period's going to be 3. So I'm all set up for that. I just have to expand this down a little bit. So I do have my plus or minus 3, so that's okay. This is y, this is x. Let's figure out the period. I do have a pi in here, so I'm going to probably have a number. So I'm going to expand this out so I can use kind of maybe the same lateral scale as far as pi is concerned. So remember the period is 2 pi over b. b is 2 pi, so my period equals 2 pi over b, which is 2 pi, so my period is going to be 1. So I can use the same scale as I did up the top so you can get a comparison. Again, this could be pi over here. I bring that straight down, so this is about pi. And that might be around 3, and then that might be around 2, and this might be around 1, and that's my new period. Okay? So now I'm only really interested in this part. I didn't really spread it out because I'm trying to give you an idea of the scale. And I'm going to go up 3, down 3, except it's going to be negative, so I'll fix that in just a second. I'll show you how to do that. There's 3, there's negative 3, there's 0. And I have to divide this into 4 parts. So I've kind of eyeball it, and this is going to go, I'm going to use pencil, like that. So that's a half. And if I split up a half, that's a fourth. And that's 3/4. So now I've got my 1, 2, 3, 4 subdivisions and my 5 points. My 0, 1, 0, negative 1, 0, basically. Okay? And now what I have to do is I have to figure my points, and I know the sign of 0, it's going to be 0 here, here, and here. That's going to be the same. Those 3 points are always 0, so you could put in those 3 points. And now we just have to figure out these other ones. That's going to be the only difference. Okay? It's always the 0, positive 1, 0, negative 1, 0. See, always. All those are always the same. Okay, got 3 zeros, a 1, and a negative 1. But I'm going to have this negative 1 is going to be affected by the negative 3. So first of all, let's take a look at this. So this normally would be 1, but 1 times negative 3 is negative 3. So it flips it. Then back to 0. Now this normally would be negative 1, but what's negative 1 times negative 3? Positive 3. So once you have your 4 points, and actually that's only 2 you have to figure out, because the other 2 are 0. There you go. Once you figure out your period, that's the main thing. And like I said, if I use graph paper or add some more guidelines, I could probably get these even better. Okay? So this is y equals negative 3 sine 2 pi x. Okay? So those are those 3 there, so you can kind of see how they're relatively comparable. I use the same scale for 9 and 13, a little different scale for 11, as far as the vertical scale. Okay, hope those help.